All right, finally, the last formula we need to derive is the formula for the range. So the range is the horizontal distance that was covered by the body in projectile motion. So finally now, we are going to begin to consider the horizontal components of the speed, which is ux. So it seemed abandoned all this while, but now we are going to work with it. Now, let us first of all solve it without the formula as our custom has been. So, we're going to use, since we're talking about distance covered, we're going to use this formula S is equal to UT plus, let me not put plus or minus yet. In fact, I will not put plus or minus because the horizontal component is not affected by gravity. So, it's just plus half at squared. But now remember, as soon as this ball was projected, it is not accelerating because there is no force that is accelerating it along the horizontal component. It is only being accelerated along the vertical component by acceleration due to gravity. So when we are considering the horizontal, because you see that the range is horizontal distance, it means that horizontally this ball is not accelerating. And you can also remember from our table we formed the first page, see that in the column of u cos theta, which is the horizontal component of the space, see that it is constant. So these two dashes, meaning it is still the 50 root 3 meter per second, so it's constant. So please, what does this mean? This simply means the acceleration is zero. So from this part, if you put acceleration as zero, you have half times zero times, well, everything is just going to be zero. Since zero times anything is zero, so you see that this part is going to be cancelled. We don't need it. So we just want to know that S is equal to initial speed times time. And remember, in this case now, since S is distance and our distance now is range, so I can rewrite this to be range, which is R is equal to UT. All right, so we are in the right track. So let's now see what we can do. No need of rewriting this. Uh, okay, let me just rewrite it. So we have R is equal to, now what's U? Remember, we can't use U as 100 meter per second because this is the resultant of the speed. We're going to use the horizontal component, which is U cos theta. So U cos theta times the time. Okay, so okay, first of all, we're not deriving the formula, we're just solving. So let's just solve it quickly. U cos theta, we already know is 50 root 3. If you do, because cos 30 is root 3 over 2. If you divide 100 by 2 is 50, then 50 times root 3, we have 50 root 3. So we have 50 root 3 times time. Now, from the table, we already know that the time, because now you see that the range is the horizontal distance from when the ball was projected to when it hit the ground again, so AC. So we're going to use, not we're not going to use the time it took the body to get to the maximum height. Rather, we're going to use the total time, that's the time of flight, which is 10 in this case. So this will be our answer. So let's put that into the calculator. We have 50 root 3 times 10, sorry, 50 root 3 times 10. So you see our answer for the range is, I'm going to approximate to the nearest whole number. So we have 866 meter. So we have 866 meter. So that is the range, the horizontal distance the body covered. So now let's derive the formula and use it and also verify. So using the same concepts, the concept I'm talking about is this. So we still want to work with this. We're still working with this. So we know that the range is equal to U cos theta times time. Now we're dealing with general cases. So we're going to have ranges U cos theta times, now the time, now we don't even know whether the time is 10 because this is a general case, but we know that the time, which is time of flight, is given by 2U sine theta all over G, right? So we derive this formula in the first part of this video. So if you've not watched the first and second part, because this is actually the third part of this video, we've derived the formula for the time of flight, we derive the formula for the maximum height. So if you've not watched it, let's put all the links in this description. Click on more, you see them. So you know how we are getting this formula. Very simple. So now let's multiply. So we have our r to be equal to. So let's just this u times this u is going to give us u squared. So we have u squared. Now we now have times 2 times sine theta times cos theta all over g. And so you see we have sine theta times cos theta, which is sine theta cos theta. Now why I'm doing this, because of the trigonometry is going to play a role here, because if you can remember from your trig ratio, or rather from your trigonometric class, 2 sine theta times cos theta is equal to sine 2 times theta. So this is a verified, formula or law. So let's just prove that. Let's say we have 2 times, let's say sine theta, let's say theta is 30 degrees. So 2 times sine 30 times cos 30. Let's verify if it's equal to sine 2 times 30 degrees. So let's verify using our calculator. So we have 2 sine 30 times cos 30. All right, if we do that, we have 0.866. Then let's also do 2 times 30 is 60. So obviously sine 60 degrees is also 0.866. So you see that I just needed to digress just to verify. So that means we are going to replace 2 sine theta cos theta with 2 with sine 2 theta rather. So we now have our range is equal to u squared sine 2 theta all over g, because sine 2 theta is also 2 sine theta cos theta, just to simplify things. And that's just it. This is one of the easiest to derive. So that's the formula to calculate the range of the projectile motion. So let's just quickly verify this again. So have our range to be equal to u is 100. So we have 100 squared times sine 2 times theta, which is 2 times 30, because that's our original angle, all over 10. So this is okay. Let us plug everything in the calculator quickly. So plugging everything in the calculator, you see that we have the same thing to the nearest whole number, 866 meter. So that is everything about projectile motion, at least the basics. So I believe if you have gone through the first part of this video, second part and third part, it should be relatively easy for you.